All right. Welcome back to the class. Dynamics. We have a question we're solving currently, and we have just gotten the velocity. Now, having gotten the velocity, the second part of the question asks us to find the position. And to get the position of this question means the displacements. Please, all noise should stop now. You get the position of this body means to find the displacement. I believe we have had enough time to write. Now let's go and get the displacement. Position means the displacement, class. We are going to visit another equation of motion that help us to find displacement. S means displacement or distance equals to ut plus half at square. S equals to ut plus half at. S represents displacement. U is 0, right? But the body starts on rest. So 0 times t is 0. So class, we are basically working with S equals to half at square. But class, displacement is also a vector quantity. So we're going to get it on the x-axis and on the y. When we want to get on the x-axis, we use the acceleration on the x. And when we want to get on the y-axis, we use acceleration on the y. For the x-axis, we use the acceleration on the x-axis. For the y-axis, acceleration on the y. Class, do we have acceleration on the x-axis? Yes. We've gotten it right. What do we have at the acceleration? What do we get that time as acceleration of the x-axis? Minus what? Someone should check your notes now. We've done the x-axis. So 1 over 2 times minus 1.5. What's our time? 1.6 all square. That's 1 over 2 multiplied by minus 1.5. What is 1.6 square? It should give you 2.56. Check. 1.6 times 1.6. Is it 2.56? Half of 2.56. Someone should check for us. 1.28 times minus 1.5. 1.28 times minus 1.5 minus 1.92 class meters. Displacement is measured in what? This is the displacement or position on the x. And let's get the position on the y-axis, class. Let us get the position on the y-axis. Will be 1 over 2 ayt square, right? What's the acceleration on the y-axis, class? 2.4? 2.5? Was it 5 or 4? Sure? Acceleration on the y-axis 2.5 times 1.6 square times 1.6. Because we're using this formula half ayt square. Half ayt square. Yes, welcome. Have you registered for the class? Where's your card? Let me see your card. Please always bring your card to class. Go and sit down, go and sit down. I know you have registered. You are wrong with the face mask every time now. Are you from the corona era? The pre-colonic era. The pre-what? The pre-coronic era. It's like she had a dream where she's always wearing face mask. So don't be showing me your card. Just wear this face mask. I know you have paid. Anytime I see you on this face mask, I know you have. Just be wearing this face mask will work for you. Half 2.5 times 1.60. Many students use this face mask to cheat in exam or a lot. Before they say no more face masks in the exam. Because nobody knows answer as inside your mouth today. You understand? You can pack answer, put inside your. You can even be asking questions. Choma, which mean number 2? Choma. Nobody seeing your mouth. Now, Choma number 2. You're using face mask to cover your mouth. Nobody's seeing the. So I think see me after the class. Let's work together. Update up. Class. Half 2.5, 1.6 square. Give you who has done the math. Minus 1 point. Sister. Half of 2.5, 1.6 square, everything. Please, if you bought a calculator you have not finished paying for, it will always give you a wrong answer. I know students last said they bought calculators. This calculator is going to be paying small. So you paid, calculator is 8.5, you paid 5K. So the answer, the calculator will be subtracting how much you are owing from the final answer together. So you did 5 plus 5, 10. Calculator removed 2K. So instead of 5 plus 5, 10, it's giving you 8. It's giving you what? Class, displacement on the y-axis is 3.2, on the x-axis is minus 1.92. So class, our displacement, if you're writing it in vector form, will now be what? Minus 1.92i plus 3.2. Class, this is the displacement, position, and this is the velocity. And we have answered the two questions they asked us to find the position and velocity at t equals 1.6 seconds. Find the position and velocity at t equals 1.6 seconds. Class, we'll now go to third law. We'll now go to third law. The unit, of course, is meter now. Distance is measured in meter, velocity is measured in meter per seconds. Unit of what again? Write it for me, write it for. So, minus 1.92i plus 3.2j meters. Class, moving forward. Third law of motion states that the Newton's third law of motion states that for every action, there's an equal and opposite reaction. For every action, there's an equal and opposite what? Reaction, class. For every action force acting on a body, there's an equal up and opposite what? Reaction. So simply put, to say action and reaction are equal but opposite to each other. Now, class, I've explained this law by saying, do you know that your weight is an example of an action? You are seated on your chair wherever you are now, and your weight is a force. The weight acting on the body is a force of gravity acting on the body. And since force is mass and acceleration, your weight is also mass and acceleration, but acceleration due to gravity. So weight and force will have the same unit because they are both measured in Newton. Force is mass times normal acceleration. Weight is mass times acceleration due to gravity. So the weight of a body is acting downward, class, but for the weight of a body to be balanced on the floor or wherever you are, there must be a reaction force, class. So I'm standing on this ground now. Why I'm not sinking down is that there's a reaction force on the ground that is supporting my weight. The reaction force always tends to oppose the weight of a body. Always tends to act in opposite direction to the force act from the weight. So while your weight is acting downward, your reaction force acting upward in opposition to the weight. And class, for there to be equilibrium or balance, the action from your weight must be equal but opposite to the reaction from the ground. Class, the first case scenario we'll look at is the elevator lift system. Let's look at what happens in the lift system. Elevator lift system. In the elevator lift system, class, some of us, how many of us have been in an elevator before? Lifts. In real life or in the dream, anyone is okay. Whether in real life or in the dream, you discover something. I'm just joking. There's nothing special about elevator. There's nothing special about. I think we have one elevator in A-B department building. Right? I don't know if they have spoiled it now. They've spoiled it. We used to have one in Senate building. I don't know. That one is only VC that is able to allowed to use it or something. So it's spoiled too. So the way you said it, is you that spoiled it. I did that job. I spoiled it. Class, if you're in a lift system and the lift is coming down and it's going up, the experience is different. The experience is when you're going down, class, you often find that you feel lighter than your normal weight. While when going up, you feel heavier than your usual weight. Class, we usually have to calculate the apparent weight or tension in the lift system. We usually have to calculate the apparent weight or tension in the lift system when the lift is going up and when it's coming down. The general formula is called the tension or apparent weight in the lift system because the weight you experience is called apparent weight, it's not your weight. That weight you experience when the lift is coming down is not your weight, it's the apparent. And that weight you experience when the body is going up is not also your weight, it's the apparent weight. It's called the tension in the lift system. And formula for that is M into bracket G plus or minus A. T equals to M into bracket G plus or minus A. Class, we have plus or minus because the body could either be going up or coming. When the body is coming downwards, when it's coming down, we use minus. And when it's going up, we use plus. Please do not confuse this with free fall motion, because we have told you in free fall motion that when anybody's coming down, it's coming in favor of gravity, you say plus, right? And when it's going up, you say minus, right? So you think that that's what applies here. No, class. In this formula, the opposite is the case. In this formula, the opposite is the what? When it's actually coming down, it is minus. When it's going up, you use plus. So they give you a question that involves an elevator or a lift system. Just remember this formula. Remember this. Let's take a question now. A boy weighing 60 newtons stands in an elevator. A boy weighing 60 newtons stands in an elevator. Once you hear elevator or lift, just thank your God. You know the formula. Yes, a boy weighing 60 newtons stands in an elevator that is ready to move. That is ready to move. Calculate the boy's apparent weight if the elevator moves upward with acceleration of 3 meters per second square. Calculate the boy's apparent weight. Calculate the boy's apparent weight. I think if you have been following our physics class before, we have now balanced to where we were before, right? You remember I started from the beginning. Normally, if I was not doing this online class, I would have gone further than this, because where we were in physics was this dynamics, right? If you are following my normal class, right? Because of the recording, I have to go back chapter 1 again, because students are resuming newly every day, and I don't want anybody to miss out. So I start from chapter 1 again. If I started from chapter 4 where I was, I would have been chapter 8 or 9 now, following this pace I'm going. But I have to go back chapter 1 again since we started doing this recording, so that you can always have access to it since you've registered for the class. Anytime you want to revise, all the chapters of each of your courses are recorded. You can easily go back and revise. So that's why we are here. But now I think we are balanced. This is exactly where we stopped in our normal class. Why I went back again from chapter 1. So if not, you wouldn't have met us chapter 4. We would have gone far. I had to start over again from chapter 1 just to help everybody. Now, class. I say a boy weighing 60 Newton. A boy weighing 60 Newton stands in an elevator that is ready to move. If the boys up, if sorry, find the boy's apparent weight. Find the boy's apparent weight. Find the boy's apparent weight. If the elevator moves upward, if the elevator moves upward with acceleration of 3 meters per second square. With acceleration of 3 meters per second square. If the elevator moves upward with acceleration of 3 meters per second square. Also find the resultant force on the boy. Also find the resultant force. Also find the resultant force. Class, we are looking for two things here. They say find the boy's apparent weight and find the resultant force. So we're looking for also find the resultant force. Class, Just to remind you, resultant force also means net force, right? Resultant force, I told you if you are following this class from net force is the bigger force minus the smaller. Class, there are two forces that are always going to be at play in the elevator: the weight of the body and the tension or the apparent weight in the lift. There are two weights. There are two weights in the lift system: the weight of the body of the boy and the tension or the apparent weight in the lift. Class, the resultant force is always W minus T or T minus W, depending on which of the forces is greater. Class, if the body is coming down, it's obvious that the weight of the body will be bigger than the apparent weight or tension in the lift. Class, because for the body to come down, the lift or elevator system must provide a weight that is lower than the weight of the body coming down, so that the body can come down. Because if there's a bigger weight here compared to the weight of the body, a body of 80 Newton cannot come down over a body of 500. So the elevator must have the weight that is lesser. The apparent weight in the system must be lesser than the weight of the boy. Meaning that when an elevator is coming down, the resultant force or net force is the weight of the boy minus the tension. When the elevator is going up, so this one is for when it's coming down. When it's going up, the resultant force is the tension minus the weight. Because when going up, class, this guy must be bigger than this to push him. A bigger force will always overcome a bit lesser. So when going up in the elevator, it's important that the force or the weight of the elevator must be bigger than the weight of the person inside to push the body up. And when coming down, the weight of the person in the elevator must be bigger than the weight of the elevator so it can come. You understand the logic behind it now, right? Yes, interesting. I remember something. For class, there's a third case scenario, but let's finish this first. Interesting. Class, let's finish this. So now, is this elevator going up or coming down? If the elevator moves upward means are we going to use plus or minus? We're going to use plus. When going up is plus. When coming down is... When going up is plus. When coming down is minus. Please take note. When going up is plus. When coming down is... But under free fall motion, when the body is undergoing free fall, the reverse is the... Normally, what you understand is that when the body is coming down, it's coming in favor of gravity, so it's plus, right? And when the body is going up, it's going against gravity, is minus. But class, that's on a body falling down naturally without a lift system. Naturally without a... But this, a lift system is introduced there, right? So the reverse is the... Yes, and if that understanding does not even work here. There are different principles. They're not even under the same understanding. Because this body is not falling down. A lift is the one bringing it down. And it's not just going up. A lift is carrying it. So when going up is plus. So M into bracket G plus... Who is M? The mass of the boy was not given, but we can get it. Class, the weight is 16 Newton. Weight, do you remember that weight is mass times acceleration due to gravity? Let us make mass set of formula divided by side by acceleration due to... So that mass is weight 16 Newton divided by acceleration gravity 10. G is a constant, right? Whether you are given or not, G is a constant. So I must get the mass, class. This question did not give us the mass. We must get the... Mass is weight all over acceleration due to gravity. And which is mass is what? Weight is 60. All over acceleration of it is what? 10. 60 divided by 10? 6 kg. So my mass is 6. My G is what? 10. Do I have my acceleration? Yes. If with acceleration of 3 meters per second square. With acceleration of what? 3 meters per second square. This will be 6. 10 plus 3? 13. 6 times 13 looks like 78. Someone should check. 6 times 13. 6 times 3, 18. 18 plus 60, 70. Is it 78? 78 Newton. 78 Newton. Now, class. The tension in the lift is 78. But the weight of the boy is what? 60. Does it make sense? Yes, it does. Did we tell you that when your body is going up, the elevator is going up, right? When the elevator is going up, the elevator must provide a weight that is bigger than the weight of the body. And it has provided is 78. So the weight of the elevator, apparent weight in the elevator is 70. But the boy coming down is what? It makes sense, right? If the elevator is going up, the weight in the elevator, apparent weight in the elevator must be bigger than the weight of the boy to move the boy. And that makes sense. So this kind of answer you get here, you know you are wrong. You know you are... But this is correct. Because the weight of the elevator should be bigger than the weight of the boy. If the elevator is going up. But if it's coming down, the weight of the boy should be bigger than the weight in the elevator. So class, we've gotten the first part. So to find the boy's apparent weight. This formula T is called the tension or the apparent weight, right? Second question, I say find the resultant force. Class, the resultant force is the bigger force minus the smaller. The bigger force is the apparent weight we just got, 78. The smaller force is the weight of the boy, 60. So resultant force or net force is 78 minus 60, giving us what? 18 Newton. The resultant force in the elevator is 18 Newton. The resultant force in the elevator is 18 Newton. Don't forget, when it's going up is plus. When it's coming down is what? You say? Why are you minusing to get the resultant force? As you're asking, you're cleaning your eyes. Yes. We added it. Okay, you came late, right? You came late. You see, you're laughing too. Class, anytime in the exam, you are saying something that is not right, check, you'll be laughing. If you are writing an exam and you have answered 1 to 10 and you see yourself laughing too much, class, it's your spirit is laughing at your carryover. Your spirit is laughing at your, so it's bringing it out of the abundance of the heart. The mouth speaketh. So your mouth is, you are wondering, this F clear that, you understand? Your spirit is laughing at you. So why you're laughing is that you came late, she noticed that when we're doing net force, we're adding, right? And she said, why are we subtracting now? Class, can we answer her? Why are we subtracting now? We subtract when the two forces are opposing. We add when the two forces are acting the same. So it's not every time you do net force that you must add. You know, before she came, I was saying something like that. That someone can just think that you always subtract or you always add. That there are different cases. And you see that it's happening now. And people learn just one thing. Because she was not around, it's not her fault. And I know she's usually coming to class. So now this one is opposing. One is coming down, one is going. So they are opposing each other. When the two forces are opposing each other, the net force is the bigger minus the smaller. When the two forces are acting the same direction, you add them. That means the forces are complementary. Are we together? So the net force is 18. That's the importance of this video. You go and watch it. The part you missed. Watch the part you missed. Everything you have been recorded, the one you missed is recorded already. Now, class, net force is 18. There's one more thing, class. They could tell us that if the elevator is moving at constant velocity, there's another formulas. Who remembers that at constant velocity, acceleration is 0? At constant velocity means that there's no acceleration, right? We have done something like this before, constant velocity, but not this question, but something like this. At constant velocity means there's no change in velocity because initial and final is the same. And this minus this, they are the same, gives you 0. 0 over t is, and it means that acceleration here is 0, means that t will just be equal to m into bracket g plus or minus 0. Now, g plus 0 or g minus 0 is g. G plus 0, G minus 0 is what? So T equals to mg. Class, if they say you find the apparent weight in an elevator in which moving at steady or constant velocity, the formula is T equals to mg. Acceleration is 0. Please take notes. Class, at constant velocity, the apparent weight in the lift system is equal to the weight of the boy, W. Because what's mg? Is mg not W? What's mass and acceleration due to gravity? W is m. Class, at constant or steady velocity, another name for constant velocity is steady velocity or uniform velocity. At constant or steady velocity or uniform velocity. I'm using all the possible names so that you will not be confused in the exam if you use any of them. At constant or steady or uniform velocity, the apparent weight in a lift system is equal to the weight of the boy. So if you are told that the elevator is moving it at steady velocity, find the apparent weight. The apparent weight T is just mass times acceleration due to, and it also means that the resultant force is 0, right? Because if T equals to W, T minus W is, now whatever is T is also W, right? So nobody is bigger than the, so if this is 50, this is also 50 minus 50. So the net force or the resultant force in an elevator moving at steady speed or velocity is what? 0. The net or resultant force in an elevator moving at steady speed or constant speed is interesting. Good. Class, the next thing we want to look at now That's what I just said now, the steady speed. Now, class, let's take a question. There's a question we have here. Class, this question they can give you a question that requires this formula, you will not know because they will never mention elevator or lift. This question came out in your exam. Okay, they will mention it, but it's not going to be mentioned at the beginning. A big lump of meat of mass 5 kg, write down. A big lump of meat, yes, of mass 5 kg. A big lump of meat of mass what? 5 kg. A big lump of meat of mass what? 5 kg. Is hung from a spring. A big lump of meat of mass 5 kg is hung from a spring. A big lump of meat of mass 5 kg is hung. H-U-N-G. Hung, right? On a spring, yes. A big lump of meat. You know, we have different types of meat. We have meat you put in food. You don't even know you have eaten it because you have swallowed it. It's just like paracetamol. A big lump of meat of mass 5 kg is hung from a spring. Balance. A big lump of meat of mass 5 kg is hung from a spring balance in an elevator. In an elevator, find the reading of the balance. Find the what? Interesting. Find the reading of the balance. A big lump of meat of mass 5 kg is hung from a spring balance in an elevator. Find the reading of the balance. If I, the elevator, is moving with a steady speed, the elevator is moving with a steady speed, moving upwards, if it's moving upwards with acceleration of 0.2 meter per second square. Take G as 10 meter per second square. Take G as what? 10 meter per second square. Say find the reading of the balance. If the elevator is moving with a steady speed, moving upwards with acceleration of 0.2 meter per second square. Take G as 10 meter per second square. Class, very quickly, a big lump of meat of mass 5 kg. Mass is what? Is on from a spring balance in an elevator. Find the, if it's moving at steady speed, what's the region of the balance? The region of balance means find the apparent weight or the tension. Find the region of the balance is simply asking you to find the what? Apparent weight or the 10. Class, G is 10 meter per second square, right? Class, what's the tension at steady speed? What's the formula I gave for tension at steady speed? T is just mg, right? So the region of the balance when it's at steady speed is mass is 5, G is 10. 5 times 10, 50 Newton is the answer to the first part of the question. Find the reading of the balance if the elevator is moving with a steady speed. At steady speed, lies, acceleration is 0. So T equals to mg. Check. In the first part, they did not even give you acceleration because there's acceleration. But look at the second part. When it's now moving upward, it's no longer at steady speed. They now give you acceleration. But the first one, no acceleration because acceleration is 0. Second part, moving upward, you use plus or minus. Let me see if you remember. Upward is what? Plus. T into bracket G plus T now equals to, what's M? 5 kg, mass is 5, g is 10. What's the acceleration they give in the question? 0.2. They give us acceleration at 0.2 meter per second square. You can look at it here. Acceleration of 0.5 into bracket 10 plus 0.2 is 10.2. 5 times 10.2 looks like 51 Newton. 51. So the tension when it's moving upward with an acceleration of 0.2 is 51 Newton. When it's moving at steady speed is 50 Newton. The last part of chapter 4 is recoil speed of a gun. Class, recoil speed of a gun. Recoil speed of a what? Gun. Class, they like this question a lot. Class, if you look at a gun, please don't mind my gun, just leave the gun like that. Unless it is the bullet. My gun is funny. If they come and rob you with this gun, you release your money. Eh? If they rob you with this gun, you release the money. Your money or your life, which one will you choose? I better take my life when my last car be this. Funny thing, I've never been robbed before. I didn't say you should come and try it, but I'm just saying. There's a funny story I've told you. One of my friends was, imagine you brought someone to come and stay with you. Just met someone on the street. And the guy said he needs where to stay, stranded. So the guy now came. My guy is someone that is very, very like merciful. So he allowed the guy to stay in his apartment. The guy was staying there. So like my guy would just go out, we go to work, come back after 1 week or 2 weeks. He's not even in his own house. This time around, they came out weekend, and this guy that he brought to his house just went out in the night. You understand? He was just going out. He went to go and buy something. So armed robbers, I don't know, some boys just saw him and held him. He's squatting with this my guy. I held him and said, please, take me to your house. I want to go and rob you. Do you have a house? Does the guy have a house? You know, these guys took armed robber to someone. They carried armed robber to what? This my guy house that you're squatting with. And then they robbed, collected laptop, collected everything, even beat this my guy on top. Imagine helping someone, the person now brought armed robber to your house. That's after that armed robbery incident. The guy said, pack your things, go with the armed robber too. Are we together? Move with it. Class, we have mass of gun, mg, and we have mass of the bullet, mb. Class, there are two masses involved here. We have the gun and the bullet. Class, this bullet came from the gun. And we also have the velocity of the gun and the velocity of the bullet. Class, we have to find the recoil speed of the gun. Class, when you shoot a gun, class, do you know that there's what we call recoil? For the gun to go forward, for the bullet to go forward, the gun must come backward. For the bullet to go forward, the gun must come. So when you shoot, class, if you watch American movies, when they are shooting, you will see this. But Nigerian movie, they are shooting like this. They have not, understand? If you watch foreign movies, every technicality involved in what they are acting at that point. If they are doing brain surgery, they will bring. If they are giving birth, see that child. Have you watched movies? See the child. Blood will be on the child, but newborn, they will even cut the placenta. But Nigerian baby, you don't born, no see the baby. But in foreign movies, they will actually cut there's something that connects the umbilical cord. You understand? The placenta to you understand? They will cut it. You will see it in the movie. You see the baby crying. You will even see blood. They should see a bit of blood. They follow all the technicalities, but Nigerian movie, you understand? They just do it. They're shooting. There's one I was watching, Evil Forest. You see the clothes in Evil Forest. You see gala nylon, like snacks. So people used to eat gala now, you understand? They don't take attention to detail. So a gun, they make that mistake too. You're shooting a gun, you're watching a Nigerian movie, they're sitting like this. No. There should be a recoil. The gun should be going backwards for bullet to go. Same thing happens in catapult. If you take catapult, what do? Back so that I can go. There must be a recoil to push. So, class, that's what we call recoil speed of a gun. Class is mass of gun times velocity of gun equals to mass of bullet times velocity of bullet. But class, there's a negative here that shows the recoil. Class, for the bullet to go forward, the gun must go So that's why the negative is here. And it's called this is a popular question they have to find. Find the recoil speed of the gun. They don't use gun, they will use revolver or a cannon. They might not want to say gun because someone has already kind of if they say gun, I know what to do. They're not change the language. A cannon was or a revolver, anything that can release bullets or pellets, anything that can release pellets. If you check your passion, you see different things. They use a cannon, a revolver, a gun. Sometimes they just say a gun. Let me just you understand different scenarios. But this is the formula: mass of gun times the velocity of gun negative. This negative stands for the recoil. The negative shows that the gun is going for the bullet to go. So if you who has seen a gun before, heard a gun before, somehow you have heard a gun before. You've heard a gun before. Now I'm not saying water gun. I'm talking about. I beg. It's for the velocity, but we are putting it here because we can't start putting it here. It's the velocity that actually caused the negative. Do you understand? Mass of gun times velocity of gun equals to mass of bullet times velocity of a revolver. You see, I said they might not say gun. A revolver of mass 6 kg releases a bullet of mass 0.05 kg. A revolver of mass 6 kg. A revolver of mass 6 kg. Let's take our first question under that. A revolver of mass 6 kg releases a bullet of mass 0.05 kg. Releases a bullet of mass 0.05 kg. A revolver of mass 6 kg. A revolver. A revolver of mass 6 kg releases a bullet of mass 0.05 at a speed of 200 meter per hour. Find the revolver speed of recoil. Recoil speed of a gun. Are you seeing it? Find the revolver speed of recoil. Find the revolver's speed of recoil. Speed of in developed countries, you can have a license to own a gun in your house. I think this Senator Ned, is trying to propose that bill that all Nigerians should have a gun. But Nigerians, I don't think we are stable and mature enough to have gun. You just see one person. Cost rep, you know, submit my assignment. Cost rep. Or one lecture I just gave you F. Or even me, self. You have not paid your therapy.